Hello everyone, welcome back to ChemCore. In the rest of this unit, we're going to describe the properties of gas, a phase of matter we're going to describe more deeply in a later unit. Scientists use models to predict the behaviors and properties of groups or categories of substances. And the kinetic molecular theory can predict the behavior of gases. Remember from your middle school science class that gases are the invisible form of matter that have no definite shape or volume. We're going to remind ourselves in depth of the different types of matter in a later unit. The kinetic molecular theory of gases can describe a relationship between measurements like pressure, volume, and temperature, as well as the properties of collisions like velocity, force, and frequency. In the last video, we talked about measurements of pressure, volume, and temperature. If you haven't watched that video, make sure to check it out before moving on. The kinetic molecular theory of gases makes several assumptions of the properties of gases for the rules of behavior to work. First, we assume that gases are composed of a large number of particles that are in constant, random, straight line motion until they collide with another particle or the walls of a container. Almost like tons of marbles bouncing around a container, the little particles that make up the gas are constantly bouncing and flying around, randomly, and always in a straight line. Second, we say that the volume of gas is negligible, or zero, because the particles are much smaller than the distance between them. So most of the volume of the gas is therefore empty space. Imagine that the actual marbles are really small, and so the actual space of the room is mostly empty. Therefore, the space the gas makes up is mostly empty. Third, we say there is no attraction between the individual particles of a gas, as well as between the particles in the container. The marbles have no care for being closer or further from other marbles, and they don't really care for sticking or going away from the walls. They kind of just bounce. Lastly, we describe the collisions between gas particles as perfectly elastic. An elastic collision is one in which the energy of each particle remains exactly the same. You can imagine these collisions as super bouncy bumper cars. When you bump into someone in a bouncy bumper car, you guys just bounce back with the same energy as you hit each other with. Once again, these four statements are assumptions. Sometimes, or actually most of the time, they don't happen. These assumptions describe gases as ideal gases or perfect gases. The gases around you right now are not ideal. They act more like real gases. These real gases won't behave according to the kinetic molecular theory. There are a couple reasons for this, including that they do have a volume, although it's really small. They do, although usually very minuscule, have attractions to each other. However, as we increase the temperature and lower the pressure of real gases, they tend to behave more and more like ideal gases. This is because the molecules move faster and are forced to be further apart, making their properties much closer to the assumption of the kinetic molecular theory. Their volume becomes more negligible and the attractions become smaller. To remember this, I like to think of the phrase, please leave the house. P in please stands for pressure, L in leave stands for low, T in the stands for temperature, and H in house stands for high. This will help you remember that ideal gases like pressure low and temperature high. In the next video, we're going to consider how the pressure, temperature, and volume of gases relate to one another. Make sure to review and practice the concepts relating to the definitions from the last video, as well as the rules of ideal gases we talked about in this video.